demonstration problem from group work quiz for chapter 3 on projectile motion from the section where y hit or y final is equal to y initial or y naught, meaning that the projectile was fired over a level surface. Putting the origin at that level surface means that y final is 0, as is y initial. So the change in y, displacement in y, is 0. The problem is Bedrick hits a golf ball at an angle of 30 degrees with an initial speed of 40 meters per second. So at the moment the golf ball comes off the golf club, it becomes a projectile because at that point in time the only force is a gravitational force. Part A, what is its horizontal range over the level golf course? So we recall that for a horizontal projectile, for any projectile, the only force is a gravitational force. And that gravitational force has no component in the x direction. So from Newton's second law, the acceleration in the x direction is the net force in the x direction divided by the mass. So since the only force is a gravitational force and it's all negative y, no x component, that means that the net force in the x direction is 0. And so since the acceleration is the net force in the x direction, 0 divided by the mass, that means the acceleration in the x direction is 0. Acceleration 0 means that the change in velocity along the x-axis is also 0, which means that the velocity along the x-axis is constant. That is Vx naught. This comes from the polar to component conversion. The initial velocity vector has a magnitude or a speed of 40 meters per second. That's the polar magnitude, which becomes the hypotenuse of this reference right triangle that's used for the polar to component conversion. Since the x component, Vx naught, is the adjacent side and the cosine is the adjacent over the hypotenuse, this says that Vx naught is the hypotenuse, or V naught, which is 40 meters per second, times the cosine of 30 degrees. We're asked for the horizontal range over the level golf course. The horizontal range is the change in x, or the displacement along the x-axis. Treating x naught as 0, that means that we need x final or x hit. And so we write down the equation for the x component of the motion. And so that is x hit is Vx naught times t hit. We just found Vx naught is 40 meters per second times the cosine of 30 degrees. This means to solve part A, we need to find the time that the golf ball hit the golf course. We have established that x hit, or the range, is equal to Vx naught times t hit. Vx naught is 40 meters per second cosine of 30 degrees, which is 34.6 meters per second. So all we need is the time to hit. We go to the final velocity not known equation, which is quadratic in t. However, since delta y is y hit minus y naught, which is 0, we do not have to use the quadratic formula to solve for this. So we write down the equation and we factor out the t and form a product and use the multiplication rule of 0, which says that t is equal to 0, or 20 minus 4.9t is 0, and use this to solve for the time that the golf ball hit the ground, and that is 4.08 seconds. So we plug that into x is Vx naught t hit, and we get a range of 141 meters. We have used the fact that the X motion is uniform motion, and so that the range, or X max or X hit, is Vx naught times T hit, or Vx naught 34.6 meters per second times T hit, which is 4.08 seconds. The range is 141 meters horizontally. There's another way to do this, but this formula only works for the case that we're looking at, or where y final or y hit is y naught, and that is that the range is the square of the initial speed divided by the acceleration of gravity times the sine of twice theta, twice the elevation angle with which the projectile was fired. And so that's 40 squared sine of 2 times 30 degrees, and that gives us as well 100. Part B, what was the maximum height above the ground that the golf ball reached? First of all, let's find the time to the top using the fact that the y velocity at the top is 0. And then we can substitute that into the final velocity not known equation, or the quadratic equation. So we take this formula, v sub y is vy naught minus gt, and set that to vy top, 0, and that is 20 meters per second minus the acceleration of gravity times the time to the top, and so we solve for the time to the top to be 2.04 seconds. We could have also used the fact that the time from the bottom to the top is the same as the time from the top to the bottom, or that the time to hit here is twice the time to the top. We had found that before to be 4.08 seconds, and so if we solve for time to the top, we would again get 2.04 seconds. And so now we take this time and we substitute that into this equation here, final velocity not known equation. And so we get Vy naught times time to the top minus half the acceleration of gravity, 4.90 meters per second, times time to the top squared. We put in the numbers and we end up with 20.4 meters is the vertical height reached by the ball. We could have also done this by using the time not known equation. That would be Vy top squared is Vy naught squared minus twice the acceleration of gravity times the y displacement, and we could have solved for the y displacement, and we would have gotten also 20.4 meters. And that's it.